Imagine finding a black hole smaller than an atom. Now imagine one bigger than our entire solar system. And then imagine discovering that some black holes might actually create brand new universes. It sounds like science fiction, but every one of those ideas comes from real physics. Most people think there's only one kind of black hole, a giant cosmic vacuum cleaner that swallows everything. The truth is far stranger, because black holes come in different types, different sizes, and some of them might not even be black holes at all. Today, we're going from the smallest black holes physicists can imagine, all the way to the ones that could be giving birth to entire universes. And trust me, the last one is the craziest: stellar black holes. Let's start with the black holes we know actually exist. When a massive star runs out of fuel, gravity wins. The star collapses inward, but if enough mass remains, the collapse doesn't stop. The core gets squeezed so intensely that it forms a black hole. These are called stellar black holes. Most are between 5 and 100 times the mass of our Sun. But despite being incredibly massive, they're surprisingly small. A stellar black hole with 10 times the Sun's mass would be only about the size of a city. Imagine squeezing a star into something smaller than New York. Therefore, its gravity becomes so intense that not even light can escape. For decades, scientists thought these were basically the only black holes out there. Then they discovered something much bigger: supermassive black holes. At the center of almost every large galaxy lurks a monster, including our own Milky Way. These are supermassive black holes. Instead of weighing a few suns, they weigh millions or even billions. The black hole at the center of our galaxy, Sagittarius A star, contains over 4 million suns worth of mass. But some are far larger. The biggest known examples contain tens of billions of solar masses. These giants are so enormous that their event horizons can be larger than our entire solar system. And here's the weird part: if you fell toward a stellar black hole, you'd be stretched apart almost instantly. But if you fell into a supermassive black hole, you might cross the event horizon without noticing anything unusual. No flashing sign, no cosmic alarm, just darkness. Therefore, the most powerful black holes in the universe are also the gentlest at their edges. But this creates a mystery. How did these monsters become so huge so quickly after the Big Bang? To answer that, astronomers started searching for something in between: intermediate mass black holes. For years, there was a gap. We had small stellar black holes. We had gigantic supermassive black holes. But where were the middleweights? Enter intermediate mass black holes. These black holes weigh anywhere from hundreds to tens of thousands of suns. Think of them as the teenagers of the black hole family. Scientists suspected they existed for decades, but finding them proved incredibly difficult. Then gravitational wave detectors started changing everything. In 2019, astronomers detected 2 black holes colliding and creating a larger one weighing over 140 suns. Therefore, we finally had evidence that black holes could grow step by step through mergers. These intermediate mass black holes may be the missing pieces, explaining how supermassive black holes formed in the early universe. But what if black holes didn't begin with stars at all? What if some were born during the Big Bang itself? Primordial black holes. These might be the strangest black holes physicists seriously consider. Primordial black holes wouldn't come from dying stars. They would come directly from the Big Bang. In the universe's first moments, tiny regions of space may have become incredibly dense enough to collapse into black holes instantly. But unlike normal black holes, these could be almost any size. Some might weigh less than a mountain. Others could rival entire galaxies. One primordial black hole could theoretically have the mass of an asteroid while being smaller than a proton. That's insane. And it gets better. Some scientists think primordial black holes could explain dark matter. The invisible stuff that makes up most of the universe's mass. Therefore, finding one wouldn't just reveal a new black hole. It might solve one of astronomy's biggest mysteries. But if black holes can be incredibly small, could humans create one? Microscopic black holes. This idea terrified people when the Large Hadron Collider first switched on. Some feared it might create a black hole that would swallow Earth. Thankfully, physics says that's not happening. The concept comes from theories involving extra dimensions. If hidden dimensions exist, gravity could become much stronger at tiny scales, strong enough to create microscopic black holes during particle collisions. But these wouldn't be dangerous. They'd evaporate almost instantly through something called Hawking radiation. Imagine a black hole appearing for less than a trillionth of a second and then exploding into particles. That's what scientists expected to see. Therefore, researchers searched for them at the Large Hadron Collider. So far, nothing. No microscopic black holes. No hidden dimensions, at least not yet. But now we're entering territory where black holes stop being observations and start becoming pure cosmic speculation. White holes. What if a black hole is a one-way door inward? Then a white hole is a one-way door outward. Nothing can enter, everything can leave. A white hole would constantly eject matter, energy, and light into space, but nothing could ever fall into it. It's essentially a black hole running backward in time. The idea comes directly from Einstein's equations. Mathematically, white holes are allowed, but nobody has ever seen one. Some physicists have even suggested that the Big Bang itself might have been a giant white hole event. Imagine that. The entire universe exploding outward from a cosmic fountain. It sounds ridiculous, yet the math doesn't completely rule it out. And white holes become even more interesting when combined with another bizarre idea. Planck stars. According to Einstein, every black hole contains a singularity, a point of infinite density, but quantum physics hates infinities. Therefore, some researchers think singularities don't actually exist. Instead, the collapse stops at an unimaginably tiny scale, creating something called a Planck star. A Planck star would be like a compressed quantum core hidden inside the black hole. Think of it as a cosmic spring. Gravity squeezes it, quantum physics pushes back. Eventually, after billions or even trillions of years, the spring could rebound. Therefore, the black hole might transform into a white hole. Everything that ever fell inside could be released back into the universe. It's one of the most fascinating attempts to solve the black hole information paradox. But one theory goes even further, much further. Baby universe, black holes. What if every black hole is actually a birth canal for a new universe? Seriously. Physicist Lee Smolin proposed that when matter collapses into a black hole, it could create a brand new universe on the other side. To us, it looks like a black hole. But inside, a completely new cosmos begins. Its laws of physics might be slightly different. Its stars might form differently. Its galaxies might evolve differently. Therefore, universes that create lots of black holes would produce lots of offspring universes. Over cosmic time, universes would evolve almost like living organisms. The ones best at making black holes would have the most descendants, which leads to a chilling possibility. Our universe itself could be inside a black hole created by another universe. And if that's true, every black hole in our cosmos might be creating universes of its own right now. Gravastars. But what if some black holes aren't black holes at all? That's where gravastars come in. A gravastar is a hypothetical object that looks almost identical to a black hole from the outside. Same mass, same size, same gravitational pull. But inside, everything is different. Instead of a singularity, a gravastar may contain an exotic form of energy pushing outward against gravity. Think of it as a cosmic imposter, a fake black hole hiding in plain sight. Scientists have even proposed more complex versions called nested Gravastars, with multiple layers stacked inside one another. Therefore, some researchers wonder whether a few objects we've labeled as black holes could actually be something else entirely. Right now, observations still favor real black holes, but the possibility remains open, and it reminds us of something important. Even after decades of research, we still don't fully understand what these objects truly are. So which type of black hole is the strangest? The primordial black holes born during the first moments of existence, the microscopic black holes that may appear and vanish instantly, the white holes that seem to run time backward, the Planck stars hiding inside black holes, or the baby universe black holes that could be creating entirely new realities. We started this video imagining a black hole smaller than an atom, but after everything we've explored, that might not be the most unbelievable idea anymore, because the universe isn't just stranger than we imagine, it may be stranger than we're capable of imagining. And somewhere in the darkness, one of these black holes might already be rewriting everything we think we know about reality.